Hello, today we are going to see about UV visible spectrophotometer and analytical powerhouse. To start with, we will see about the source that are utilized in this UV visible spectrophotometer. For the visible region, usually tungsten filament lamp is used. It looks like somewhat a bulb only. The tungsten filament, it consists of the filament tungsten and it gives the radiation region of 350 to 800 nanometer, which is the visible region that is used for the analysis. So any sample which are colored, we can directly use tungsten filament lamp because it covers this visible region. And how this source works is, it is also called as incandescent lamp that produce light through the heating of tungsten filament that is there here to very high temperature. So when the filament is heated by electric current, it emits continuous spectrum of visible light. So the light that is given out depends upon the temperature. So if the filament is heated, if it is warmer, then it will go to high intensity, and to the shorter wavelength region it will go. So it is dependent on the temperature. They are robust, reliable, and it's widely used for the source of the visible region of light. Other source which is commonly employed is deuterium lamp. It is best when compared to hydrogen lamp. Hydrogen lamp is also used as source for UV region, but deuterium is far more superior than the hydrogen lamp. So we will see the working of this, and before that I will just like to tell you that it gives the it can be used as a source of light to produce light of the wavelength 190 to 350 nanometer. So mostly in UV region. And how it is operated is, we'll pass electrical discharge through a deuterium gas. This is filled with deuterium gas. So when we pass the electrical current, the deuterium molecule will be excited, and due to this, emission of continuous spectrum of ultraviolet light, that is from 180 to 350 nanometer is produced. And the emitted light depends upon the applied voltage and also the gas pressure that is within this lamp. So they are used commonly as the UV source in UV visible spectrophotometer. And thirdly, we will see about the mercury vapor lamp, or it is also called as mercury arc lamp. And this is not a common source of light in UV visible spectrophotometer. Why? Because this is actually due to the excitation of mercury atom, and it produces it won't produce a continuous radiation of light, but it produces a discrete line emission. So at specific wavelength only it will produce. So it is a discrete line spectrum that will be produced out of it. It is not a continuous, as it is not a continuous radiation. For a general purpose, it is limited to use this source, but we can use this to calibrate the wavelength accuracy of the spectrophotometer. Next, we will see the schematic diagram of the instrumentation of the UV visible spectrophotometer. We just saw about the source deuterium lamp and tungsten filament. So in this scheme both are located, because so that all through from UV to visible region, every wavelength region could be explored and utilized when we have both of the light that are installed in the instrument. And depending upon the sample, we can choose the radiation range, radiation wavelength region which we want to analyze. So first is we have the source, and then we have the filter. Filter will select the wavelength to some extent, and then we have the monochromator which will select the wavelength of the incident radiation which goes to the sample. And here we have the beam splitter. So coming off from the monochromator, we have a beam splitter which bypasses some amount of the radiation from the source, that is from the monochromator to the reference sample tube, and the remaining amount of the beam from the beam splitter goes to the sample. That is, this beam from the monochromator is split, and simultaneously it's sent through the sample and also the reference. So what is the reference is? It is the solvent in which the sample is prepared. So if water is the solvent, water will be the reference here. If some ethanol, acetone, any other solvent means, the reference will be that particular solvent. And we have the detector here. In this case, we have photodiode. We have other detectors also, like barrier layer cell, photomultiplier tube. Several other detectors are there. Mostly used is photodiode. And then the together result is processed and the graph is given, which will be more accurate. So when we go for a double beam UV visible spectrophotometer, the various unwanted noises, everything could be easily eliminated, because it will just the reference beam and the sample beam both are analyzed. That time any other unwanted noises in the spectrum could be easily eliminated. Next is sample handling. We have this sample tube like this one which is shown here. This is the sample tube or the cuvette that is used. It can be made up of glass, it can be made up of plastic, and it can be made up of costly quartz also. So these are the tube in which we will keep the sample. And the sample preparation, usually we will use a dilute sample. So whatever the sample it is, we will dilute it so that Beer-Lambert's law applies. We can filter it also, so that if it is like turbid and all, definitely you will have a disturbance in the recorded value. So it has to be clear, so it has to be filtered, and if required, other kind of treatment can also be used to get a proper spectrum. And sampling technique is depending upon the instrument that we use. You can use a different sampling technique, like direct injection, flow injection, stop flow, anything we can use, or just place the squirt inside the sample holder. Next we will see about the detector in detail. First is this photomultiplier tube. As you can see, it is actually first of all a costly detector, but it is very sensitive. That is where its importance arises. Why? Because very small intensity of the absorbance, very small absorbance also could be easily read out using this PMT. How is, we will see this schematic diagram, and I'll explain now. So for example, if you can see here, so the photons of light that is coming out of the sample, okay, if it falls on this one of the cathode, these are called as dinodes. So if it falls on this cathode, it in turn emits electron. It generates electron. So this light striking a photocathode, and uh, the correspondingly electrical current will be generated out of this photocathode, and then the electron will be accelerated towards a series of diodes, and each one after the other is maintained progressively higher voltage at each diode. For example, if it is 2 volt, that is 3 volt, 4 volt, 5 volt. So progressively at higher voltage it will be maintained. So the amount of electron or electric current that is ejected out of each of the diodes, after if it is getting reflected here and from here it goes here, every time it gets magnified. The current that is coming out from the photons that is incident on it, and when it is undergoing this process, it is much magnified. So even a small amount of absorbance could be easily read out as a peak or a spectrum in the resulting graph. So that is a main advantage. But in order to use this PMT in a UV visible spectrophotometer, very high voltage also needed to operate this. So that facility also is needed, and then it is likely to get damaged if the light intensity is high, because here itself if it is high means that means very dilute solution if you use, some it can damage this. So that one disadvantage is there. Here we'll see about photodiode. So photodiode, in this photodiode we use semiconductor which is like a p-n junction. This semiconductor material we will use here. Uh, so that's a main difference. And so the light from the sample, when it gets incident on this p-n semiconductor, electron hole pairs will be generated, and this electron hole pairs will be generated in proportion to the light that is incident on it. So the electron hole pair, it will conduct current. So this light is converted into current, which is measured, and it is very convenient, less expensive when compared to PMT, but it is less sensitive also. Um, and it can be used in a very wide range. Many applications they are using photo diode only, and they are less susceptible to damage. So it is very useful. Now we will see the law governing this UV visible spectrophotometer, which is Beer-Lambert's law, which is nothing but A is equal to epsilon CL, where L is the path length, that is quit with size, it is always a constant, might be 1 centimeter like that. And then epsilon is the molar absorptivity. Okay. It's also specific to the analyte and the wavelength of the light that is used. So the value of epsilon actually it depends upon the analyte chemical structure also. Its electronic transition at a given wavelength, both the factor, the structure of the analyte and the wavelength, both the factor it is dependent. Now we'll see the application of UV visible spectrophotometer, just outline of application. So in pharmaceutical analysis, they say that no API, active pharmaceutical ingredient. So we can identify and quantify that API, very important thing. And then environmental thing, the pollution, water quality, monitoring some adulterant in like that, and studying environmental changes also could be easily done. Mostly the photocatalysis reaction, dye degradation, everything. UV visible spectrophotometer is very handy to study those kind of experiment. And in food chemistry, we can analyze the components that are there, we can measure, quantify the color, the intensity of it, and then we can easily detect the adulteration in food product. And advantages and limitation, if you talk about advantages, is simple, it's versatile, and it is widely applicable. And limitation is this is applicable only in this UV visible region of the electromagnetic radiation.